Hey everyone, it's Canfield. Today we're going to look at the review packet that I gave out for the quiz that's coming up next class. So I'm not going to do every problem, specifically because I do not have enough time. I only have about, what do I have? I got like half an hour. So I'm going to go through and do some from each page, focusing on ones that are really important. And all of my work has been uploaded to Schoology already. So yeah, you can just get it there. All right. So first question says, am I skipping this one? No, I'm not. Okay. So I did this one in class, but it's worth doing now. It says, find the slope of the secant line between x equals 3 and x equals 4. So that's really saying between the point 3 comma something and 4 comma something, find the slope. And to do that, we literally just go to this, plug in 3, plug in 4, get our numbers. So you can use your calculator for that, which I'm going to grab mine really quick, or you can plug them in by hand. And I made it pretty clear that on this one, it's going to be in the calculator section, so like whatevs. All right, so I'm going to use the calculator. All I got to do is go in, put the top in parentheses. If you don't put it in parentheses, it'll be wrong, because that's how we have to enter fractions. And I'll go to my table. Oh, I want to set up my table, so I'm going to push second window and change the independent to ask. That lets me then, when I go back to my table, so now I'm able to enter in 3, and I get -1/2 or -0.5, and then 4, I get -2. So I do recommend this when you're trying to calculate things. It saves you a lot of time. Okay, so if I go into a slope formula, I'll do -2 minus -0.5 over 4 minus 3, and that's going to be our slope of the secant line. So I don't need to do this. So if I do the arithmetic, the top turns out to be -1.5 because of the double negatives there. And the bottom's 1, so then it's -1.5 or -3/2 if you did this all with fractions. So then this says find the slope of the tangent line at x equals 2. And just remember in class, the way that we've done these so far is just through an approximation. So the approximation that we've done will use 2, but then we'll use like 2. Sorry about the blip. So we'll use 2, so we'll get 2 comma 0, and then, or you can like 2 x values that are right around 2 if you want to use like 1.99 and 2.01. This is not the way we're ever going to do it ever again. This is just to give us like oh, if I got really close and found a secant line, it's very similar to what the tangent line would be. So like here when I do that, I get -3 and then it says e-4. That means that I move the decimal place 1, 2, 3, 4 places that way. So 1, 2, 3, 4. That opens up a 0, 0, 0. So that's -0.0003 when x is 2.001. And we also had 2 comma 0 that we got from our table. Okay, so I find the slope between those two. So finding that slope, I'm going to skip the work for this. I got -0.3, and I'm skipping the work because it's identical to this. But feel free to let me know if you have actual questions with that. I'd be happy to work with you. So that's my slope, and it's an approximation. It's not the real thing. There's a way to use limits to get the exact answer here. So then it says find the equation of the tangent line at x equals 2. So I'm going to pretend that I want to use slope-intercept form to show you why this is the bad way to do it. So I know the y value is 0. I know that m is -0.3, and I know that x is 2 plus b. Now I need to solve this for b. So I have 0 is equal to -0.6 plus b. I'm trying to make my b and my 0.6 look different. I'll add the 0.6 to both sides. So I get 0.6 is equal to b. So I'll get y is equal to -0.3x plus 0.6. So that's like the point or slope-intercept way to do it. The better way to do it, and I like to say it's better because it's not actually better. There is, it's all about what your personal preference is, because better is subjective. So y minus the y value, and it says at x equals 2. So I know it says x minus 2 over here, and then the y value was 0, so I'll say y minus 0. And then my slope was negative 0.3, negative 0.3. So I'm done here. If you use slope-intercept form, you're done 4 steps in, which is super annoying. All right. So I'm going to do one more of these, and I'll do this one. So I'm going to skip this because this is more of the same. So it says, if an object travels a distance of s is equal to 2t squared minus 5t plus 1, where s is in feet and t is in seconds, find the average velocity. Average velocity is rate of change of distance. So secant line gives us average rate of change. Secant line gives us average velocity if we have distance. So what I'm going to find out is I'm going to find s of 0, and I'm going to find s of 10. And I'm going to kind of cheese my way there instead of actually having to do real, actual work. Because why would I do this by hand when the calculator can do it for me? Ooh, I skipped an important detail. Okay, so I got 0, 1, and 10, 151. The important detail that I missed is it says in the first 10 seconds. So whenever we're talking about time and it says like the first amount of seconds or something like that, we're always going to, when we start our timer, it always starts at 0 and then goes from there. So you really want to think, okay, 0 to 10, not 1 to 10. So I do slope with those. I'll get 151 minus 1 over 10 minus 0. I know this is s's and t's, but it's really x's and y's. T is x, s is y. You know, it works the same way, just different letters. And so I got 150 over 10, which is 15. And since I know it's feet and it's seconds, I can say feet per second. So there's my average velocity in the first 10 seconds. Now, if I wanted to find instantaneous velocity at t equals 3, again, we're going to learn a real way to do this that's very fast, and you actually can do it in your head. But we don't know that yet. All we know how to do is say, well, I know I could find 3 seconds and find the y value there, or sorry, the s value there. And then I could do like 3.001 seconds and then find the y value there and find the slope between those two. So when I used these two numbers, I got 7 feet per second. I'm not going to finish this here again because I'm strapped for time, but feel free to call me out if you get something different. Leave a comment below if you can. If you're on school property, you can't. I don't know. Send me a message on Schoology, email me, whatever. Tell me I'm wrong. Please let me know when I'm wrong so I can fix things. So I'm skipping this one, and then we're on to these. So I'm not going to do all of these. I'm going to do some of them. Each problem has 6 parts. So basically, I'm looking at this graph. This is f of x, and it says the limit as x approaches 1. And with that little minus sign, that means from the left-hand side. So if we're looking at the limit as x approaches 1, we're really looking right here, right? We're saying, hey, as we get closer to this bar from the left-hand side, where are we going? So if I follow the function, get closer and closer and closer and closer and closer, the y value that we get to is 1. The y value never actually hits 1. It's just going there, and so our limit is 1. Then we look at it with a little plus sign. That means from the right-hand side, we do the same thing. We go da-da-da-da-da-da-da, and we're like, oh, hey, it goes up to 3. I am going to, on this paper, I'm kind of assume that the guy meant to have it like line up perfectly. I can tell that I think he used Microsoft Word, and the shapes in Microsoft Word are really finicky to get to move around. So that's why you have like this little ugly overlap here, and even down here how there's that little break. Like that's not supposed to be there. He just was struggling with Microsoft Word. So which I don't fault him for. Microsoft Word is a pain to do this stuff in. So on this one, it looks like it's trying to go to 3. If it's on a calculator screen or if it's computer generated, then it's going to be a lot more accurate. Like if you use Desmos or something. So our left and right limit. Left hand's going to 1, right hand's going to 3. They don't match. It means there is no limit. And then we ask ourselves, hey, what's the y value when x is 1? So this is saying like what the left and right hand are doing. That's what limit means. But this one's saying, hey, what's the actual dot? And there isn't one. So this also does not exist. I'd say undefined, that's like the more traditional term, but who cares? If your teacher cares, I'm sorry. I'm not trying to talk down on what they're saying. I'm just like, whatever. I know what you mean with D&E, like it's undefined, sure. So here we're going down. I'm sorry. This one says, hey, go to negative infinity. That all these problems have at the end, you go to negative infinity. So on this one, you go to negative infinity. So as we travel to the left, we see that it's going down. And remember that it continues forever. We can just assume that he's trying to continue forever. If there had been like a dot on the end, that is like, okay, he is definitely stopping. But since there's no dot, we assume that he meant to put the arrow and just couldn't be bothered to. So down to negative infinity. If we travel off to the right, it's also going down. So we'll say negative infinity again. Then if we go to number 2 is kind of similar, where we're coming in from the left, coming in from the right. First to 2, so it's going to 1 from the left, like up to 1. From the right, up to 1. And so that means the limit is 1. But the dot is a little bit under the x-axis. I'm going to assume he tried to make the dot right there. I'm going to say the dot is 0. And then now as we go off to the left, it's going and going way down, so we can say negative infinity. As we go off to the right, you could argue, no, it's totally stopping. I'm not really going to argue with you on that. I think you've got a good point, but I'm going to say, hey, no, he means like it keeps on going down like that. Having played with Microsoft Word, trying to get graphs to look nice in it, I know that he just used there's like an arc, and the arc inherently has this weird hook at the bottom. He's not trying to represent a special function with that. He's just kind of dealing with his technological limitations. So I shouldn't spend any more time talking about that, because it's not interesting unless you have to do it for a living. All right. Next. So, similar scenario, the only different thing to talk about here is there actually is an f of 3 and it's at 0. That's because that one's filled in. 4, I like number 4. What's the limit as x approaches 0? From the left, it's going to 0. From the right, it's going to 0. That means the limit is 0. But what's the actual y value? Oh, the y value is also 0. That's totally fine. As we go off to the left, it goes and goes up, so we know it's going to positive infinity. As we go to the right, it goes down. We get negative infinity. All right. This one, you're going to have a limit that exists, but you won't have an f of 1. And then this one is pretty straightforward. The one we go off to negative infinity, though, in this one, it's flattening out, and so there really should be like a horizontal line to indicate to us, like definitely it's flattening out, but it is flattening out to 0. And so as we go to negative infinity, we can say, hey, it's going to 0. So again, I am skipping through. Feel free to check my PDF on Schoology if any of these, if you're curious about what I got for any of these. No. So now we have a couple other things to talk about. So like in this one, as we go off to negative infinity, we're going to approach that asymptote of -2. Should be dotted. That one, I can fault him. You click on it, there's a setting to change it to a dotted line. But you're not here for my quiz review. You're just here for my quiz review. So you don't need me to review this product and tell you how good or bad it is. I think it's an outstanding product in general. So this one, as we're going to 1 from the left-hand side, we're going up to positive infinity. You don't need to write the plus. I'm writing it to emphasize that we're talking about positive. And then from this side, we're going to negative infinity. Hey, those aren't the same. That means there's no limit. And then like on this one, though, as we approach 2 from the left, it's going to positive infinity. From the right, also positive infinity. That means its limit does exist, and it's positive infinity. Well, okay, the limit is infinity. Infinity is not a number, so infinity is a type of non-existent limit, but it's important for us to know if it's positive, non-existing, or negative, not existing. And that's different than this situation where it's like the left and right don't meet up, and since they don't meet up, it just plain doesn't exist. So we'd say the left and right hand don't agree on this, left and right hand limits. This one, the left and right hand limits do agree. It's, if you want a fun term for this, it's increasing without bound. It just goes up forever into the boundless expanses of space. All right, anyway, number 10, this is going right? It's oscillating. And so as we go out to infinity, its limits don't exist because there's no place where it lands. It just continues to do this oscillating behavior. Same thing in number 12 as we go off to the left. There's no limit as we go off to the left to infinity because of the oscillating pattern. But to the right, you can see that it is getting smaller and smaller and smaller. So as we go to positive infinity, it actually will approach 2. So onward and upward. So, wow, I didn't think I was going to have enough time. I might have enough time to get through everything I think is important to talk about. So, take the limit as x approaches 4. There is no x. It's just the number then. Take the limit as x approaches negative 4. Oh, so like I just use direct substitution and plug it in and get negative 16. Yes, that's it. Take the limit as x approaches negative infinity. All right, well that's 5 times negative infinity plus 1. That's negative 5 infinity. Wait, that's just infinity, but like negative. And you add the 1 to it, but who cares about the 1? It's a baby. So we get negative, I almost wrote negative 5 infinity. So we get negative infinity. All right, number 4, plug it in. Number 5, you might be confused and think that you're not allowed to plug this in because there's a denominator. Does the 3 mess up the denominator? No, just plug it in. So do like 9 minus 1 over 3 plus 4. I did 3 squared to get 9, and negative 3 times 3 to get negative 9. So we get negative 1/7. And then number 6, I'm going to try plugging it in. Just let me see if I can get, so I get 16 minus 4 minus 12. Okay, so that's going to be 0. And then here I get 16 minus 36 plus 20. Oh, that's all. Okay, I have 0 over 0. Okay, we said it's indeterminate, which means I can factor and try canceling. So in the top, I will look for 2 numbers that multiply to 12. Oh, that's negative 12. Oh, hey, that inherently tells me I need a positive and a negative number. And when I add them up, I have to get negative 1. So 6 and 2 won't work, because if I were to make one of them negative, I'd be getting a 4 or a negative 4. But if I try 3 and 4, and it turns out to be negative 1, so I'll need the 4 to be negative. That does work. And the denominator, same deal, but this time we're multiplying to positive 20, which tells me either both positive or both negative. And I got to get a negative 9, so double negatives. So that's 4 and 5, because 5 times 4 is 20, 5 plus 4 is 9. We haven't actually taken the limit yet. We've just simplified things. So I'm going to leave the limit notation here. I'm going to do some cancellations. And now I can plug it in. 4 plus 3. 4 minus 5. Negative 1 on the bottom. Negative 7. I'm just going to double check my work from earlier today. Okay, cool. I just want to make sure I'm getting the same answers I was earlier. Especially when I'm rushing, I make silly baby mistakes. So, not like the baby is silly, but the mistakes are tiny, like the size of a baby. So this one, hey, x is going to infinity. That's a horizontal asymptote. Find the horizontal asymptote. Well, my biggest power of x in here is 1, so I have 4x to the 1s on top. I have 5x to the 1s on the, oh, I'm done. This one, going to negative infinity. So that's all the way to the left. So biggest power of x I see is x to the 1. On top, I have no x to the 1s. On the bottom, I have a coefficient of 1. 1x to the 1. 0 divided by 1 is 0. All right. I'm so smart. Let's see, this one, I plug in infinity. I see x cubed, that's my biggest x power. So on the top, I don't have any x cubed. On the bottom, I have 0.01 x cubed. 0 divided by 0.01 is 0. So let's keep going. All right, this one. This is the first one that's a little bit tricky, so let me just be careful as I talk about it. On the top, so x to the 8, that wins. And we're going to negative infinity, so that's telling me, hey, be careful here. So the top is going to, there's a 1, so I have 1 on the top, I have 0 on the bottom. So I know my answer is going to be 1 divided by 0, which is undefined. But as we do limits, we're allowed to say that that's infinity, especially as we go out to positive or negative infinity. But you need to be careful. So I just want to think about what the sign of the numerator is and what the sign of the denominator is going to be out at negative infinity. So if I think about negative infinity to the 8th power, that's going to wind up being a positive number. Well, infinity is not a number, but positive, really, really big infinity looking thing. The bottom is going to be 1,000 times negative infinity to the 5th power. And like, who cares about you? That little plus one's not irrelevant. It's not going to affect the sign of that because that's so much bigger. That is going to wind up being a negative number. And so because of that, a positive divided by a negative, this is going off to infinity, and this tells me it's going off to negative infinity. So not the only way to do it. We're going to learn something called L'Hopital's rule in a couple of months that is going to show us, like, if we're ever getting stuck on these, not sure which one to do, it will always lead to the right answer eventually. Don't worry about it for now. If you can kind of reason through that, you'll be good. There's no difference of cubes in this packet, but difference of cubes is definitely something that pops up. I needed to get done in the next 5 minutes or so. This one, you can factor the top a couple of times to cancel out the x plus 2. This one, when you take negative infinity to the 4th power, you have out on the top and the bottom, those negative infinities don't wind up staying negative because they both get taken to an even power, and you just wind up with negative 3 over negative 6, which is positive 1/2. I would accept either of those as an answer because the AP exam would accept either of those as an answer. All right, 13, we're approaching 5. Uh-oh. We get a number over 0. Number over 0 means asymptote. 0 over 0 meant we can probably factor and cancel and do stuff. But number over 0 means asymptote. And so I'm going to use that little table. I'm going to use, the numerator is x, the denominator is x minus 5. I'm going to have a spot for a number just a little bit less than 5, so like 4 point, lots of 9s, and then like 5 point, a bunch of 0s. I'm being comical on purpose here. So, and then a 1 at the end. If I were to try 4 point, then, oh yeah, and the asymptote's here. So 4 point, and plug it into x, well, it's a positive whatever the heck it is. Similarly here, if I plugged in the 5 point string of 0s and then a 1, if I plug this into x, it's a positive number. Over here though, if I plug in 4 and a bunch of 9s into here, we wind up getting a slightly negative number. And here, 5 and a 5 point and a 1 minus a regular 5, the 5s like cancel and we're left with that little tiny positive. And so because of that, the sign of f of x is going to be, well, this says positive on top, negative on bottom. A positive divided by a negative is a negative. And here, a positive divided by a positive is a positive. That leads me to say, oh, so over here on the left-hand side of our asymptote, it's going wee, and over here on the right-hand side, it's going whoop. And so since those are not matching up, we're able to say that this limit does not exist. I'm not going to say you can't do that in your head. I'm sure some people kind of think through these things. You don't have to use this table. This is an organizational tool. 14 is similar. It just has a couple more moving parts, but it's the same idea. If you make that a little chart like that, it'll work out. And I won't spoil the answer. 17 and 18 both have a problem with them. And 15 winds up going to both to the same one. I think they both go to positive infinity. There's a spoiler for you. 16 and 17, they both should be asking the question, like, what's the limit as x goes to 4 of f of x? And 17 should be saying, what's the limit as x goes to 0 of f of x? Without them, it's just saying, hey, here's what f of x is. And you're like, what's the question? No, I'm just telling you that's what f of x is. So a reminder for these, you're really just saying, hey, well, x is 4. Oh, hey, those kind of switch over at x is 4. So I just take turns plugging 4 into both of those. And I want to see whether or not they are equal to each other. So on this one, we get 16 minus 6. On this one, we get 12 minus 2. So I get 10 on this side, I get 10 on this side. Oh, hey, from both sides, it's going to 10. That means the limit is 10. If we had gotten two different numbers, it doesn't exist. I'm going to move on to number 2. So I did a little bit of just cutting and pasting in their PDFs, so I couldn't edit the text. And this is where, like, I just put another piece of paper over on top. I know. I know I'm the worst. Okay. This one says find the limit as x approaches 6 of f of x. Show all proper steps. Ooh, proper steps. So really what I want to do is say, I don't care what happens when x is 6. I care what happens when x is coming in from the left and the right-hand side to 6. Well, that's this function. X squared minus 5x minus 6 over x minus 6. Whenever it's this, like, we just say, hey, if you plug in 6, like, what would you get? So I try plugging in 6. I'll get 36 minus 30 minus 6. Hey, wait, that cancels. 6 minus 6. That cancels too. I get 0 over 0. Uh-oh. So that means I can do factoring, right? I can factor the numerator. And I always want to say 2 and 3 because I see 6 and 5, and I'm like so quick to do that. But one's plus, one's minus, and they have to add up to negative 5. So it actually is a 6 and a 1, and the denominator was a hint. The denominator says x minus 6. It doesn't always work like that, but sometimes for problems like this, the denominator is like, hey, you probably want to try this as one of the factors. It probably works. And I haven't taken the actual limit yet, but I'll plug in the 6. Oh, I got 7. So if I want to be proper, I'll put the limit notation here. And then I'll plug in the 6. 6 plus 1, I got 7. Woo! All right. So that's the limit. And this says find the value of k such that the limit, oh wait, the limit, it's that number. And word to the wise, if you can't get this number and you're doing that, you can make up this number. Like, you can still do this problem and say, oh, well, 7 is supposed to equal to f of 6, the y value when x is equal to 6. Oh, well, the y value when x is equal to 6 is 3k plus 2. But what's k? K is not x. K is a different number. Oh, but I can solve it. I got 4 is equal to 3k. Divide both sides by 3. Divide both sides by 3. I think I got a different number than this when I did this earlier today. Can't feel it. Did you guys know that 7 minus 2 is 4? 7 minus 2 is 5. All right. If I haven't told you this before, I've gotten D's on tests where I knew how to do everything because I've just loads of little mistakes like that. Okay. So I got that k is equal to 5 over 3. Okay. So hope this video was helpful. I know I kind of ran through things quickly, but hey, that's what slow down and pausing are for. So again, you can feel free to check Schoology for other stuff. I hope you do well on the quiz. Let me see, what can I say? Let's let me throw in it, like if you've made it this far, I think, and if you tell anybody, if I find out that people are telling each other this, I am not going to give this to anybody, but I'll give you a couple bonus points if at the top of your paper, like on the very beginning of your quiz, if you put something along the line, let's see, what should it be? You should write, hey, Mr. Canfield, I rule. Sincerely, me. So, at the top of your paper, write, hey, Mr. Canfield, I rule. Sincerely, me. You do that, throw you a couple bonus points, because that shows me you read the video. Read the video. Wow. All right, what else stupid things can I... Have a great day, everybody. Bye.